Hey guys, welcome back to another episode of Simuleos, the only channel on Twitch exclusively devoted to computational... Wait, that was my old tagline. Sorry about that, getting it out of my head. Here's the thing, we are doing kind of different things today, so I can no longer say we are exclusively devoted to computational physics. I haven't been able to say that for a while, but it kind of was stuck in my head, and now every time I start a stream, I start to say it, it just happens. Sorry about that. Anyway, okay, what are we doing today? Well, you can see at the top of the Twitch page, which I can go to really quickly, we are drawing with code. So this is something we did a few days ago, right? We used Cairo to do some drawing and stuff with code. That's pretty cool, but we didn't get very far with it. So what I want to do today is kind of explore our options, go a little bit further, because it took us, you know, an hour, maybe, to get out a good PNG and try to do some examples, but I couldn't get very much farther than that. Now, I haven't really touched the code since then, because there were a few months ago when I started touching the code outside of stream, people started getting mad at me because they'd come back and they'd never know what the code was looking like. So what I decided to do was instead to study how Cairo works in the time off. And this has helped me tremendously, and I think I'm going to show you guys what exactly I learned and then go from there. So let me go ahead and open up Zernal and describe what it is, or how my understanding of Cairo is right now. So I wrote down all the notes in the notebook that I've been using for everything else. So hopefully this will go kind of smoothly. Okay, so I'm not going to go through all the Cairo commands because there are a lot of Cairo commands. What I need to talk about, if I can find my drawing pad. And I know it's ironic that I have a drawing pad and I'm using programming to do the drawing. I get that. Okay, what I need to talk about is how Cairo draws. So first of all, what are we doing? We are drawing. Now, here's the thing. One more thing I want to point out. We could have done just about anything today. It's just, this is kind of what I wanted to do. And there's a reason for that. In the end, what I want to do is I want to get a YouTube video out of this kind of stuff. And I figure, hey, look, I'm currently not able to draw worth anything. You know, here is an arrow for me. You know, here are two eyeballs, smiley face. I can't draw worth anything. But I figure I could probably write a code that could draw for me. And could do all the drawings and make it much more consistent and really high quality. And I figure, since I'm kind of sort of about to do my next YouTube video, not necessarily today, but maybe next week or something like that, I should probably go ahead and get this drawing stuff done. More than that, it's the weekend, and I figure, hey, we could probably do side projects on the weekend or something like that. So I realized, even though you guys didn't vote for this, I'm interested to see whether you guys enjoy it or not. So please, before leaving, or doing whatever it is you plan to do today, leave a comment in the chat letting me know if this is up your alley or it's not up your alley. Again, this may or may not be a one-time thing where we do separate things on weekends. Let's see, a while ago we used to do Fortran Fridays, where we do some sort of Fortran code on Friday, and then we tried to switch it so that we do any language, so that's how we started doing Julia. But then again, something started happening where we do the project only on Fridays, right? And because I didn't want to work so much on the code when I wasn't streaming, it ended up being that that project kind of was delayed and delayed and delayed, and it was really hard to really work on, because every time we started coming back on Friday, it took much longer to get back into the habit and things like that. With this, I feel it's a good project just to have on the side, just to work with, you know? And so it's one of those things that if I'm stuck on a particular problem, which happens a lot, where I just don't have enough time to research the topic beforehand, or something like that comes up, this is something I could just pick up and I could do, and it doesn't take a lot of time. And that's kind of nice. So drawing, what are we using? We're using Cairo. Now Cairo, let me go back over to my internet browser, is a C++, or really any language. I think it's also Python API. Let me see. And it's got these cool little dune beetles as as their logo. I guess that was drawn in Cairo? I'd be very surprised if it wasn't. Okay, so we're going to the documentation, and we're going to go to tutorial. Now, in tutorial, they start by talking about these nouns, and I figure I can describe these to you guys now. Oh my gosh, every single day it always starts with a yawn. Okay. Nouns. We've got three basically layers that we need to talk about. 1, 2. Actually, I'm going to draw them in different colors. So I'm going to draw the top one in black, even though I just erased it. The next one I'm going to draw in blue. And the next one I'm going to draw in red, or green. There we go. So what are these guys? Well, this guy down here is the destination. It's where all the stuff is going to be written to. So it's kind of like your screen or your canvas in a way. This guy up here, the black guy, is your source. And the blue guy in here is actually incredibly interesting, and it's called your mask. Now, the mask, and again, this is coming from someone who knows absolutely nothing about any type of artistic suite or anything like that when it comes to programming or actual art or anything like that. I know basically nothing. One second. Good. So, forgive me if I say something stupid. But the mask is essentially your paintbrush. It is the thing that relates the source to the destination. Now, in this case, it's different than a typical paintbrush, right? It's not like, it's more like a stamp in a way. So you've got, you could just draw a single line, but you could also draw shapes. You can fill in the shapes. You can do whatever you want. So this could be your mask in a way, just some sort of weird shape or line or something like that. Basically, imagine putting down a template and then spray painting the template, and that's kind of what we're doing here. And that's actually incredibly interesting. Now, the next thing we need to point out is there's this thing called a context, and I guess this will be in black again. The context is everything we want included in the diagram we're talking about. So it's one source, one destination, and one mask. And this is something we define in the code itself. Usually it's defined as like CR or something like that. And there's a whole bunch of different, I guess you could call them types and things like that Cairo has that we kind of have to consider when doing this kind of stuff. Okay, now outside of this, it's got a whole bunch of commands: stroke, fill, show text, paint, mask, which will change the mask, straight, which is straight line, arc, curve, and then a closed path. So the idea is we could actually provide Cairo a bunch of values, and it can draw a shape along those values. So if we wanted to make, like, I don't know, some sort of weird parabolic trajectory, we could do that. I think that'd be interesting. But I'm not exactly sure how to do it yet. So what I want to do today is I want to kind of just test with Cairo, see what we can do. The first thing I want to do, when we were working on, end curses, the thing that does the terminal GUI, we were able to create these things called windows, which were essentially blocks inside of our big block, which would in this case be the image. And in these windows, we were able to manipulate only things inside the windows. It's kind of like in VI, not Vim, but in VI, when you press backspace after entering insert mode, if you haven't inserted anything, it will not go past that point. So the idea is that we have some sort of window, and in this window, we can only manipulate things here. And I kind of want to make basically 3 of these. And now I think you're seeing why I want to make a webcomic out of code, because I'm very bad at drawing. If we want to do 3 of these, 1, 2, 3, we could essentially get the webcomic format that most people see, or are used to, or something like that. Anyway, I want to try that first. Then I want to try just plotting random shapes and things like that, because I think it'd be kind of interesting to see how hard it is to plot these shapes. So I think, so far as I'm aware, direct plotting is not allowed, but we have this thing that allows us to draw a curve. And if we draw a curve, we could draw a curve across a number of points. There's a few other questions I have as far as what the numbers mean when we insert them and things like that. If we're drawing a line from one point to another point, I don't know what the lines mean or what the numbers mean in the function arguments. So there's a lot of things like that that I have questions about that I'd like to answer. But again, if you have any questions, comments, concerns, or if you just want to come in and talk, do whatever it is you want to do, let me know, I guess, in chat what it is you want to do. And we can talk about that during stream. It doesn't necessarily have to be about the project at hand. Usually when it comes to the scientific topics, people will ask questions related to the topic at hand. But for this particular case, because we're not doing so much in terms of, actual grappling with, questions and things like that, just feel free to ask anything you want. In terms of future plans, just for the record, so you guys are aware, we're still going to go back to DMRG probably Monday. What we need to do is we need to go through and finish up the diagonalization routines, which we pretty much did yesterday. We got to a tri-diagonal state. Then all we have to do is further diagonalize it. What else was it? Yeah, and then after that, we can actually do the DMRG stuff. And I think we could probably get that done during the following week, maybe the week after that, which is fine. The next weekend, I intend to do another video on YouTube about diagonalization, which I think is really cool because it tells about eigenvalues and things like that, which are also really, really cool. What else is there to talk about? I think, yeah, and then after that, there will be a video on YouTube about DMRG, probably 2 weeks after we finish DMRG or something like that. I'm going to try to put up a video every other week, which is significantly faster than the amount of time I've been putting up so far. And if you guys want, I can show you guys the editing on Twitch. I could do some sort of editing video, and that's fine. But I don't think it's particularly interesting for you guys, so I probably won't show it otherwise. I might just drop weekends and work on YouTube on weekends or something like that. Good, so that's all I have to it to do today, or to say today. Let's go ahead and get started, and we'll see how far we can get. Again, the point of today's stream isn't necessarily to do a lot of physics like the other streams are. The point of today's stream is just kind of to get used to the feeling of Cairo, how it works, why it works that way. So we'll be flipping back and forth between the internet and the terminal and a few other different things. And if you have any questions, just let me know, and I will totally answer those questions as soon as possible. For now, let's cd into projects and subroutines. Cd projects. Subroutine. Okay, let's go here and ls. I should have, yep, I have a make file. I have a hello.png. Let's go ahead and remove all PNG files. Okay, and for the record, let's remove subroutine. And I think I can do that with just a make clean over here. Good. I realize you guys are super quiet today, so that means one of two things. It could mean that there aren't very many people watching, which is perfectly fine. This is, again, not our typical stuff, so it's not a big deal. And even if it were our typical stuff, I was kind of gone for a month and a half, so I can't really complain when people don't show up to stream, because it's not even complaining, really. It's fine. I'd like to request a stream dedicated to Fortran coding, because I've never seen it. I've always heard people in comp talk about how they learned Fortran back in time. So with Tuck and yeah, sure. We used to do Fortran all the time. In fact, if we go to, let me see. I was actually planning to do subroutine in Fortran. One second. Let me do, is this possible? Installation Cairo Basics in GTK Fortran. Cairo Basics. Nah, there's nothing I can do here. Fortran tutors. I thought maybe that there was a way to use Cairo in Fortran, but that's fine. Here, one second. Let me show you some Fortran code, and you'll see why it's not typically used. Let's do Simuleos optimal control. No, it's going to be in archives optimal control. Oh, what? One second. I'm missing something. Simuleos optimal control. ls. And we should have a nilderme.f95. Okay. So, here's the thing. In Fortran, you got to be very careful about how you write Fortran code. Now, in Fortran code, I always use subroutines. I know functions are technically more efficient, but I always use subroutines because it's Fortran. There's a whole bunch of things about Fortran that are actually really nice. For example, when you're writing something, here, this command right here, this is saying we're writing something in a default format with default content, right? However, if you want to put in anything here, you could put in, we're not writing it to a default, so again, default place, default way. right? So this could be your default screen, which would be your terminal screen, and this could be your default, just whatever it is. So in this case, it's defaulting to basically a string or a character index. But what you can do is you can actually go down here. I'm sure I have a template or one second. One second. Do I not write anything to screen ever? Oh, I guess I don't. Maybe I don't here. In terms of writing to files, it's actually incredibly easy. Because all we do is we label the file as a number and we put it there. You know, it's so easy when compared to like C++ where you have to import fstream and stuff like that. Or in C where you have to use printf, and printf is really unintuitive. Here you just create some sort of a file, you put a label on it, and then you create some sort of format. You put a label on that, and then you can output data in that file with that format. Super easy. There's a whole bunch of other real good reasons to use Fortran. Now, these interfaces aren't necessarily one reason to do it, but there are a bunch of good reasons to do so. So here's an example. We open number 100, and we give it a file name, and then we can immediately write out to that file name. It's really kind of neat. Let's see. The other thing is in Fortran code, in case you've never seen Fortran code before, you always put 6 spaces before every line in Fortran code. And that's because of some really, really old school ways of thinking. The idea was that you have 80 columns to work with. And to this day, I still work in 80 columns. I think that 80 columns keeps your code clean. And for me, as someone who usually pulls up code in multiple terminals, kind of like this, except I normally have more terminals available, having an 80 column code makes it so easy to read and so nice to work with. So I always keep to 80 columns. But in Fortran, you always worked with 80 columns and you put 6 spaces before every single line. And the 6 spaces were actually because of, well, I guess the reason you were limited to 80 columns. Way back in the day, you were limited to 80 columns because you were printing it out on some sort of card. And that card was being read through a machine. And the 6 spaces before every line were basically a method or a way for the machine to grab, the card. So it left some space on the card so that you could put a wheel and run the card through the machine. And that was kind of the idea behind the 6 spaces. It gave the processor like a way to grip the card to read it through. And so to this day, whenever I code in Fortran, I always put 6 spaces before every line just because of the absurdity of having 6 spaces before every line to begin with. It's kind of fun. I really enjoy. Fortran is one of those languages that frustrates me to no end, but I'm never sad when coding in Fortran. It always makes me happy because it's just, there's so much legacy code, like so much history in writing the language. It just feels like, I don't know, it feels great to code in Fortran, and most people hate it, and I understand why most people hate it, but it's still as fast as you're going to get for many numerical routines that people do as physicists. So it kind of makes sense to work with every once and again. Anyway, that's my Fortran tangent. Now on to subroutines. So let's go ahead and go over here and let's run the make command. When I run the make command, ls, I now have a subroutine.png. If we open that up, you remember, as of last time, we had a bit of a problem here. Oh, my bad. Subroutine.png. PNG. Yes, so we scroll in here. And I don't know what I did, but I screwed something up. Okay, and I think this is because I didn't really understand what it was I was doing. So let's go into the subroutine code. So subroutine.cpp. Okay, so if you remember, as of last time, we were perfectly able to create text, and we were able to show the text and things like that, and that was great. But here, we're not necessarily able to do that. So what I'm going to do is I'm going to manipulate this guy. I'm going to work with it a little bit, see if we can, do some stuff on our own, draw some patterns, get some stuff out there. Good. So I'm going to get a quick sip of water, and then we can start doing that. So again, I was planning to draw this stuff in Fortran, but I decided against it because, well, it's Fortran, and I was somewhat afraid that there wasn't any way to actually do the drawing. Now, there was one thing that I saw that seemed really cool in terms of drawing with Fortran. It actually showed people creating videos with Fortran, but it was like a 500-line Fortran code, and I was like, I don't know, it's not very well documented, and it was clearly just written by some guy in his free time, and I didn't want to commit to it, you know? Okay, so let's go ahead and start working with Cairo. Here's what we got. Cairo surface team. This is the type of the surface. Cairo image surface create. We're creating an image surface. This is a 10 by 10 pixel wide. I want to change this to 100 by 1,000 pixels. Okay. Now we have Cairo create surface. And we go down here and we've commented all this out. But this is essentially our way to create text and show it and stuff like that. So it's not so bad. Cairo pattern T, rad pattern, lin pat. This is a radial pattern and linear pattern. And what I want to do right now is I want to just remove this. I don't see any reason. What is this 1010? Cairo create linear 1010. What happens if we change this to 100? 100. Let's see if we make it. Let's make clean make. Okay, now let's go into the subroutine mirage subroutine.png. Okay, well this is not exactly what I had in mind. So let's go here and let's change these guys up. I guess the first one then has to be width. So let's change this to 1,000, and let's change this to how about 400. Okay, let's go down here. Oh, sorry about that. Let's go down here and let's see. So we have a radial pattern here. Let's see, we have size Cairo rectangle. So this is just basically creating a whole bunch of rectangles. But let's say I want to do this a little bit differently. Let's say I want to Cairo set source. That's fine. Wait, what? 1 second. All right. Yeah, don't worry about those curly braces. No one cares about those anymore. Okay, rectangle. Let's just create a single rectangle at a single point. Okay. So this is going to be at, I'm guessing. Yeah, so this is drawing our guy. And apparently we are, let's see, j divided by 10 minus 0.4. I'm not really sure what this means. So I think, let me see, we have 4 values here. 1, 2, 3, 4. I would assume that this is the XY position of a top and bottom, I guess, square to draw, right? Because this is setting the rectangle. This is changing the mask. This is changing the design in a way. So it seems to me that if we increase these guys, let's go from 10, 100, 10 to 100. I'm not really sure. Maybe this is starting point and then width. So here's what I'm going to do. I'm just going to set all of these guys to 100 just to see if these guys are actually setting size. 100. And then we'll go from there. Okay, here we do draw width. Let's do make clean, make, and then let's go into the image again. Okay, so this did something. I'm just not sure what we did. So let's see. If we scroll in here, zoom in. Did I break it? How do I keep breaking this thing? Okay, so I guess end process. Let's try that one more time. Scroll in. No, apparently I cannot scroll in. Apparently this particular image is just a bad image. Okay, that's fine. We drew something though. Maybe there's a better way to view it. What's a good image viewer? Ocular? Mirage. Oh. Subroutine.png. Yeah, okay, well here's again our random line. I want to zoom in. There. Okay. We drew. I don't know what that is. Okay. That didn't help me very much. Hey, I love Twitch. School's finally done. 2.5 months of free time. Fantastic. So today we're kind of doing something a little bit different than what we normally do. So I understand if it's not your thing, but thanks for coming back, man. I do appreciate it. Okay, so let's see. What do we have here? We drew something. I just wish I had half an idea what it was that we actually drew. Cairo, create pattern. Man. Add pattern to color stop RGBA. This probably isn't. It is exactly Cairo, yep. Cairo paint. Cairo fill. What happens if we do Cairo fill instead of Cairo paint? Let's go over here. Make, clean, make. And again, this is just kind of us learning how this works. So I understand if you guys have anything that you want to talk about that's not related to the project at hand, I totally understand and I'm willing to talk too. So again, let me just know what your thoughts on different things are. Okay. I'm clearly doing something stupid here. I'm not exactly sure what it is I'm doing. So what I need to do is look up the, I'm just going to try something on my own. So I'm going to delete all of this since it doesn't really matter and it's up on GitHub anyway. So let's delete this guy, and let's just make sure we can create an initial image with some sort of text on it. Right here, go to make clean, make, then we're going to do the last, I guess, ocular. Yeah, hello world, pink. There we go. It's perfectly fine. Okay. Now what did we do there? We said we're selecting a font face. We're selecting font size. We're selecting source. RGB. Also fine. Cairo moved to. We moved to somewhere. And then we printed hello world. Now here's the thing. What I found out when I was going through Cairo is that every time you want to show the text, you actually don't want to move to exactly any given pixel. What you want to do is you want to move to the pixel you want to go to, subtracting out the size of the text itself. And this sounds kind of weird, but it kind of makes sense, right? I mean, I don't know. I guess this is just one way for Cairo to know where it is you're actually going to be putting the text. So that's pretty useful. Okay. Cairo paint with alpha, that's fine. Okay, so we have here, Cairo move to show text. Good. Draws a line with pixels of draws a line of width pixels thick. Let's change this to 10. And let's Cairo move to 0, 0. Let's just draw a single line across the top. Okay. Make clean. Make. Oh, make. And then ocular subroutine. There we go. So. What? The line is already skewed, and I don't even. Okay, Cairo line 2. Oh, that would be why. Let's just have it. Let's have it 10. Let's start it at 10. Right here. Go over here. Make clean. Make ocular. There we go. Look at that. It almost looks like I'm doing something. Okay, so now let's see if we can draw rectangles and do some more complicated stuff. Okay, so we're already drawing things, we're already writing things. That's perfectly fine. Cairo stroke will draw everything that we want it to draw. I want to now create a rectangle. Okay, so let's go ahead and create a rectangle. Okay, how do we need to do this? Well, first of all, how do we actually do this? So to create a rectangle, we have, let's see, where is it? I have something here. I know I have something here. Cairo create surface, context, stroke, fill, show text, paint, mask. This has to be it. Yeah, there we go. Hey, Guster1, thanks for coming in. Okay, so we have Cairo pattern, create radial. That's fine. But what I want to do is I want to create a... I wrote down all the commands in my book, but this isn't really helping any. I want to just create a rectangle. So I think it's just Cairo rectangle. But I can find that pretty easily online. So let's go here, do rectangle. Okay, that's exactly what it is. Now here's the thing. I don't know what 0.25, 0.25, 0.5, 0.5 mean. I don't know the units. So let's just create a rectangle and let's stroke it. It's probably a good idea. Stroke and rectangles. Okay, Cairo set source RGB. Yeah, let's do all this. Why not? We'll do all this. So I'm gonna go over here and we're gonna do Cairo out line width of the current CR, which is going to be our current. Well, see, here's the thing. I don't think it's RGB yet. Here, I'll show you why. So we do Cairo. Let me see. CR, which is our current context, which is, you know, a combination of everything else. And we haven't stroked anything yet. So it's going to be CR. And then we give it a line width. And I'm going to give it a line width of, let's do 0. Oh, no. Let's do 5. No, 50 was fine. Let's just keep it 50. Set line width. Yeah, we'll just keep the line width exactly what it was before. Okay, so now what we need to do is after setting the line width, we then need to set the color. And this is going to be Cairo set source RGBA, doesn't matter. Set source, if I can spell source, RGB. And then we say the current context, which is going to be CR, and then we give it some values. Is that i3 window manager or no, it's something else. This is actually OpenBox is what I'm using. Now I always set the terminals up the same way. And so what I do is I actually have certain commands, like for example, if I pull up a terminal, I press Windows L, it will automatically, it'll automatically tile one way, and that way is left. Now when I tile right, which is of course Windows H, it does tile that way, but it also resizes the terminal to fit onto the right. So all of these terminals, if I had 4 terminals up, are standard sizes, but the one on the right is always a different size. Except for when I'm streaming, which is the direct opposite. This terminal is not sized correctly, and these 2 terminals are sized correctly. So this is going to be RGBA. Let's make it a blue rectangle. So 0, 1, 0. And then let's go down here. And let's do... I think it's just Cairo rectangle, right? Cairo rectangle. Setting it probably on the current, whatever it's called, context. There we go. Now it says 0.25, 0.25, 0.5, 0.5. But again, I don't know what those values mean because we already set the color before. So this is why I don't think it's color. This has to be the size of the rectangle because we're dynamically changing the mask, which is basically that, what's it called? The brush, in a way, the stamp that we're putting onto it. So let's go here and let's change this up. So let's try from pixel. Let's try doing what we did before. Maybe I just screwed it up before. So let's see what this does. And now we're going to do Cairo stroke. And we stroke the current context. Okay. See what happens if we make clean, make, and then we run the last ocular command. Okay, so this actually drew a square. Fantastic. It has to be from 100, 100 to... Oh, it is of size 100, 100 at position 100, 100. That's what we've got. Okay, so, but it's green. RGB. 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 Why is it green? What is green? Green is a mixture between green... Oh my gosh. The G does not stand for blue. It stands for green. Okay. That would explain why it's green. My bad, guys. Okay. So let's change this to a 1. Now it's going to be blue. Okay, so let's change this around. So my guess is that this is X, Y position. This is X, Y size. So what I want to do is I want to change this to, let's change it to 500. And let's change this to 50, 50. Let's go over here and let's do make clean, make ocular subroutine. Okay. Yeah, that's about right. That's what I'd expect. Okay. So now let's see if we can get this right. So I want to know X, Y. I want to know what it is that we're actually looking at. So I'm going to set this one, which I believe is X, to 0. And this is also going to solve another question we have. And this one, which I believe is Y, to 100. Okay, so this should create a large rectangle up in the upper left-hand corner of the image. So make clean, make. And now let's do ocular subroutine. Okay. This is a little different than I was expecting. Okay, so I thought that this 0 was X, but this 0 is apparently Y. This 0 is apparently X. This 0 is apparently the X dimension or width. And this is apparently the height. So apparently it's X, Y, Y, X, which is weird, but not all that unexpected, because this is, yeah, Esham, that's exactly what it was. Oh, no, it was YX width height. Okay, so here, this is what we have here, Cairo rectangle, and we have 50, 0, 500, 100. So this should create a long rectoid. Is that a word? A long rectangle this way, and it should be positioned at the very top. No, wait. You're right, Esham. You're right. I was wrong. I'm just being an idiot here. I was right before. Let me go in here. This is me being an idiot at 5:30 in the morning. I apologize. I don't know what I'm thinking. Look at this image. That is clearly at 0 on X. That's clearly 0 at X. This is clearly 50 at Y. I don't know what I'm thinking. This is the third time this morning, and it's only been 40 minutes that I've made some sort of stupid vocal mistake like that. But you're right, Esham. I'm wrong. Here's what we got. And let me, I guess, remove this. No, that didn't help at all. Let me resize this guy. Oop. Here. Okay. It is clearly XY with height. Exactly as you would expect. I was just being stupid when I was interpreting what it was that was up. Okay, so we can draw rectangles. Now, we want to add in a dynamic mask. And what I also want to try is this Cairo fill command. So if we do Cairo fill context, it does weird things. So let's do this. Oh. I feel like I hope that's not what it means, because then I just accidentally, yeah. But maybe it is. Okay, Screamer Chaotix, thanks for coming in. Yeah, this one should be pretty easily understandable, and you'll learn that I'm nowhere near as, I guess, good at things. Okay, so Cairo filled the rectangle, right? And that's exactly what you'd expect. But here's something I don't understand. I'm going to draw 2 rectangles, and I want to see which one Cairo fills. Does it fill both rectangles? I have no idea. So let's go here, and let me do this. Let me create a second rectangle, Cairo rectangle, CR, and this is going to be at the same X position, but it's going to be, let's see, it's 100 wide, so 150 would be the next one. So let's do 200. Then we're going to do 500, 100. So it's the same size, but it's shifted down a little bit. And now I'm going to do Cairo fill rectangle, or Cairo fill, and let's see what happens if we do make clean, make, and then ocular subroutine. It fills both rectangles. Okay. Now, this is the thing that's weird to me. I'm sorry. This is the thing that's weird to me. I don't understand. What if I just want to fill one rectangle? I guess I'd do this. I'd do Cairo fill. Here, let's see what happens. Cairo fill this rectangle. And let's do Cairo rectangle. What am I doing? Rectangle. Then we want to do this 0, 50. Oh, I'm sorry. I want this to be at where it was before. So 200, 500, 100. And then we do Cairo stroke. And I think this should do it. Okay, so we're going to do make clean, make, and then we're going to do ocular subroutine. Got it. Fantastic. Okay, so now we can go ahead and start creating the boxes. Now the question is, how big do we want the screen to be? And that, that may not be the right question to ask, actually. Okay, so first of all, if we're trying to create a webcomic, we probably want everything in like a webcomic-y format, right? So the question I have, and I want to answer right now that I kind of sort of understand how to do this kind of stuff, is, how do I, let's just try something. Okay, I'm going to create a single box, I suppose. And I'm going to write into that box. So let's go up here and let's just mess around with some things. So first of all, Hello World is up here. That's perfectly fine. Cairo set source font size is 32. Also perfectly fine, but it's kind of big. So what I'm going to do is I'm going to draw a line of width pixel thick, but I want width to be much larger. So I want this to be 50, again, like 50, not 500, like it was before. Then I want to move to 0, 0, 1,000, 0. So it's just a line across the top. And I'm going to change the color to blue. Okay, so we have a blue line across the top. Now, what I'm going to do is I'm going to take these guys, and I'm actually going to move them just before the Cairo stroke. Okay, so let's remove font size. Move to show text. Show font face. I guess that's fine. Select font face. Okay, set font size 32. No, I don't want this to be 32. I want this to be 12. Okay. Now what do we want? We want set source RGB. We've already done that. That's blue. But I want to rechange this to... Oh, this is going to be interesting. I want to see what happens. Let's change this to pink again. And also, Screwy Cadex, I don't know if you're being serious or not about the being modest thing. So let me just say I apologize in advance if I have been a little bit arrogant or anything like that. My defense is that I'm a physicist. And whenever you come across a physicist in the wild, you know, like, I don't know, the savannah or wherever physicists live, in general, they are very bad at being modest, because it ends up being that they'll say something like they'll do some sort of crazy physics that no one can follow. But because they understand it, they assume that everyone else can understand it, so they say it's easy, and then it comes off as very, very arrogant, and sometimes I do that, so I apologize for that in advance if that was what you were talking about. Okay, so can I move to 100, 100? No. I want to move to 0, 0, and I want to see where the text is actually printed. Oh, thanks, man, then I appreciate that. Okay, so let's go ahead and write this. And we have two rectangles being generated under the big thing up top. Now what I did, and I don't think this is going to work. Yeah, not arrogant. That's way different than what my boss says. Okay, set line width. Okay, so here's what I think happened. We took our source, we changed the source color from blue to pink. So I think we're just going to see a large line on the top, right? I don't think we're going to see the large line and also hello world. You ready? It's gonna be a test to see how Cairo works. Right over here, make clean, make ocular. Yep. Oh, yep. Yeah, that's what I expected. Okay, fantastic. Oh, I guess because we set the line width very large. So let's go down here and change the line width again. So create rectangle. Oh no, that's also interesting. Look down here. This bottom rectangle is larger than the top rectangle. And this is because this one was stroked. Stroked? Sure, why not? And this one was not. So because of that, this one was filled. So it just filled everything inside. and this one has some sort of width to the thickness that is the exterior of the rectangle. Okay, so let's go up here and let's mess around with some things. So I want this to be that color. That's fine. Then I want to stroke it here. Okay, then I want to show text there. And now we should see hello world randomly. Well, not randomly, exactly where we expect it to be. So make clean, make, and now let's do ocular. Okay, so this is what I was afraid of. Let's zoom in here, scroll up. I mean, that looks pretty good. Okay. Hello world, what is this? That's not what I want to see. So let's drop this down because I guess it was fairly obvious that we wouldn't see hello world. I mean, maybe to you guys, not necessarily to me. So can I remove to, let's move it to, the width is 50, so let's move it to 50. Oh wait, that's an X. We want to move it to 50 here in Y. Okay, let's go here and let's do make clean, make, and let's see what happens if we do ocular subroutine. Oh. Oh. I betcha. 1 second, let's try this. Make clean, make. There we go. That little thing we saw down at the bottom was actually the comma of the hello world. And kind of interesting, maybe not that interesting. We see. Thanks, Husky. I've been working on my CSS skills. We see something else that's kind of interesting here. This top block, which I said was supposed to be 50 pixels wide, is actually only 25 pixels wide. And I suppose, again, that's fairly obvious because, let me go back into the image. The width is 50, right? And we're starting it at 0, 0. So only half of the width could appear. Okay, so what I'm going to do is I'm going to change hello world color to white, which will be, I suppose, 0, 0, 0, right? Or 1, 1, 1? Let's see. If R and B together is... Maybe it's 1, 1, 1. Oh my gosh. I'm a physicist and I don't know how colors add. Let's do make clean, make ocular subroutine. Good. I was worried there. Okay, so what we need to do is we need to increase the font size. So I set it to 12 because I wanted to see how big this guy was. So if we do ocular subroutine, is this okay? Maybe, but I want to change this a little bit. So here's what I'm going to do. I'm going to, I need to find a way to arbitrarily size this guy, this canvas that we're working on, right? So let's go up here and let's just define. Okay, I'm gonna create a function here. So let's do that. Function to, what are we gonna do? Function to draw initial layout. Should be fine. So here's what I'm gonna do. I wanna draw a line across the top and I wanna draw 3 boxes. Just a standard 3 box, or a standard, I guess, number of boxes. We could read in the number of boxes we want, and then size of the canvas. And then we want to return that. So what we want to return is Cairo T, which should be, and this is the thing I'm curious about, if we just return the context, is that all we need? Or do we need more than that? I have no idea. So what I'm going to do is I'm going to return a Cairo T and go from there. So, Husky, algorithms in Java. I've got a question. Do you like Java? Java to me has always been a language that does not come intuitively. You know, in some sense, I wish it did, but it just doesn't to me. And this is, of course, you know, it might come very obviously to other people, and that's fine. Okay, so let's do it. Cairo T. Wait, I'm thinking again. At some point, we're going to have to draw inside of these blocks, right? Now, like I said at the start of stream, when we were working on end curses before, there was a way to create windows, right? And these windows were basically areas that you would edit. And anytime you started talking about anytime you started talking about things inside of a window, it would be related to the size of the window. So if you put a window on, let's say, you know, maybe it's 50 columns thick and 50 rows thick or something like that. So it's pretty big. When you say 1, 1, it's going to bring you up to 1, 1 of that particular window. And I'm debating, should we do the same thing with these boxes? I feel like we should. So now, okay, let's just create this first, and then we'll go back and see, hey, do we want to actually do more with this? And Husky, I guess that's probably fair. So when I started programming, I guess in C++ a very, very long time ago. But then the language that I really started programming in was actually Fortran. And so of all the languages that I know and I feel like I understand, Fortran is number one. I feel like, I know this one. It's kind of like Doctor Who. You always remember your first doctor. So I guess programming languages are like doctors. I guess. That's probably a very bad way to put it. Okay, so let's do Cairo T. And what are we going to call this? We're going to call it create scene. And we don't need to read anything in, I don't believe, not at this point. Good. I don't know anything about the book, so I can't help. But you guys feel free to talk about it. Cairo T, create scene. Do we need to read anything in? Let's read in the initial height and width. So we're going to say, oh, no. We don't want to read in the initial height and width. We don't. Because if we have 4 boxes, that's going to be dramatically different than if we have 3 boxes, which is going to be dramatically different than if we have 1 box, right? So the shape of the image has to be modified. So what we want to do is we want to give it an initial width, but we don't want to give it an initial height. So we're going to do int. Oh, I guess it has to be int, right? It's pixels. Width. Is that fair? Because see, now I'm thinking, okay, if we have it an initial width, that doesn't really help any. Oh, I'm just overthinking it. I'm totally overthinking this. Let's just write something. And in the worst case scenario, after writing it, we have to revise it, right? Who cares? So first of all, the first case scenario that we're going to do is without reading in anything. Create scene. Okay, so I'm going to create some tags here because this code might get kind of long. And we're just going to signify what part of the code we're at. Of course, I always do this because I use VI. And I always like to have very particular tags that I go to when searching through the document. So for example, if I ever want to go to main and the document's rather large, I can always just type in $main and it brings me right to this tag. And I also, at the very bottom, always add in another guy, which is subroutines. That way, I always know exactly where to find all of my functions. I guess it's fine. There's multiple subroutines, so let's do that. Okay. So now what are we going to do? We're going to do this. Nope, we're doing this. Okay. And okay, so now let's go ahead and add this guy down here. Function to create the initial layout. And let's try it. So I guess I want this to be a freaking huge object, you know, incredibly large object, because the larger the object, right, the more resolved it will be when we kind of squunch it up in the end, right? I think. We'll see. We'll see. I know nothing about graphic art or graphical art. I know nothing about anything really. So let's do create context. And I'm going to get down here. Yeah, that's fine. We're at the bottom, but that's fine. So create initial. What do I need to do? Surface and context. Good. Let's go down here. And what we're going to do is exactly what we have up there. So Cairo, image, oh, surface T, and then star, surface. And this is going to be equal to Cairo, image, create, oh, image, surface, create. It's right there. Now, Cairo format, ARGB, this is A, which I don't know what A stands for. A is alpha, I think, and then red, green, blue. So Cairo format, ARGB 32. And then we're going to give it a size. And here, maybe we should give it... Okay. I am going to give it something. Box. How about num box? We're giving it the number of boxes. Okay. I missed some chat. Let me see. What do we have here? I did like some JavaScript stuff when I was maybe 15 or so. Interesting. I thought, okay, let me see. But it seems like a really good book. Haven't read CLRS, but since I personally write in Java, this book is more natural. Yeah. I think it's kind of fun to implement them in your own choice of programming language. I honestly bought because MIT OCW uses it in its online course. OpenCourseWare. Yeah. Actually, oh, I probably shouldn't say this. I'm going to say something else instead. I've been thinking about OpenCourseWare a lot lately. And I've been thinking, if I could have a job, and my job was specifically doing OpenCourseWare, like creating lectures and things for people to listen to online, learning about things so that I could teach other people, I think that'd be super cool. Like, sure, it's not research, but it's still super cool, and I think it'd be super fun. Okay. Good. Okay, so what do we have here? Int number of boxes. So we're reading in the number of boxes. And let's go here and say, quickly, note the size of the surface is dependent on the number of boxes. Okay, so now we have to create some sort of way to get this done. So first of all, we need to create, okay. So the boxes need to be of a particular, I guess you could say, size and shape, right? Typically they're, I think, a 4x3. Would that be right? Let's see. Let's just go online and look up webcomics. So xkcd.com. That's maybe not. Okay. That's a clear rectangle. Okay, so these are all... I never thought I'd go through webcomics on this stream. Okay. So let's just do random. Okay. See, these are the boxes I was thinking of, right? Something like this size. So let's see. We have... Oh, I'd say that's probably 4x3. No, maybe closer to 16x9. Flipped on its side. Let's go to another one. 2gag.com. This is actually one of my favorite webcomics, by the way. Yeah, that's definitely. That seems like a thing. Hey, Captain626, how are you? By the way, guys, I think I can't pronounce the word captain. Like, I really think I have trouble pronouncing that word because every single time, like, for example, Captain America, I always pronounce it captain, not captain. I don't know what it is. I just cannot pronounce the word captain. It's like takes effort for me to pronounce it. Okay, so this is 2gag. Why am I looking up webcomics? Yeah, this is This is probably about what I want. Sorry. So Captain 626. If it bothers you that I'm saying Captain 626, let me know. That's okay. Yeah, so we're just doing Cairo stuff today. It's just, I don't know, it's a lighthearted stream. It's not difficult, I think, to understand. I think most people can kind of intuitively grasp what it is that we're doing, and I'm doing my best to kind of explain it as we're going along. Okay, so what we need to do now is dynamically size the surface itself depending on the number of boxes that we want. Now, this isn't the easiest thing to do. So let's say we want the width to be 2000. Okay. Oh, gosh darn it. Let's say when deciding the surface size, we assume a set width. I'm the same way with saying regularly. Fair enough. There are also certain words that I can't pronounce. Like, for example, okay, like, my family always makes fun of me because I pronounce Tootsie Pop funny, apparently, but I don't know how I'm pronouncing it funny, and I've never understood how it's supposed to be pronounced. So, like, there's certain words that I apparently am not pronouncing appropriately. Sixth is no, sixth, that still gets me. I can't do the word physicist. I have a lot of trouble pronouncing, which is why I usually say like physics researcher or something like that. The word physicist itself, I'm very bad with it. Hypersphere FTW. Have I ever made a game? Hypersphere FTW, I have not actually made a game before. Well, let me rephrase that. I have, if you go to github.com, let me see, there should be, where is it? Let me go to my profile. You're going to hate this. I'm sorry, Hypersphere. I'm really sorry. You're going to hate this with a burning fiery passion. We made a game that was a terminal-based academia-themed card game. And it was actually super fun. We made it in Ncurses. It was in the terminal. Lots of fun. But no, I've not made a game in a traditional sense. Okay. What else are we saying? English is my third language, so there's a lot of words. I don't know how I'm actually supposed to pronounce it. For some words also stumble on similarly. Similarly, I think it's fine. What? Husky, I enjoyed it. It was super cool in the end. The game was kind of like, the idea of the game was that you have to get a certain impact factor to win, right? And so you do these things, you'd like hire people. It'd be a lot of fun. Agario? What is Agario? Is that the one with all the bubbles? Oh, yeah, I've seen people play this game. Let me think. Agario. Is it on GitHub? Let me see. Not sure that was what I wanted to do. Is it on GitHub? Did you say fork or clone? You said clone. Oh, okay. Well, apparently people have already cloned it. So maybe this is what you need? Sorry, I'm not very good with graphical interfaces in general, unfortunately. Sorry about that. But if you're interested, I don't think the underlying physics is very difficult, so we could create a game that does the same thing, just I'm not very good with graphical interfaces, so I wouldn't really want to work on that project very much. Sorry about that. Okay, so set width. Should we assume a set width? How do we do this? Okay, let's assume that the boxes themselves need to be of a particular size, and then we just fill everything appropriately. So we assume a set width of 2 boxes. Okay? Now, the box size is what we should read in. Got it. So now we're going to read in box size. So we're going to say box height, box width. Width. Width always comes first, right? Oh, come on. Int box width. Int box height. Good, let's go down here. Well, I wouldn't necessarily call myself skilled. So here's the thing, when it comes to computer science, and I think most people who do a lot of computer science totally agree with me here when I say this. Of course, let me know if you guys disagree. Oops, sorry about that. If you disagree with what I say, I'm not going to be mad at all. So here's the thing. That was actually kind of cool. I was talking and typing at the same time. Yeah. Okay. What am I going to say? When it comes to computer science, you can know a lot in one area, but you might not necessarily understand every area. So just because you're able to code does not necessarily mean you're good at everything. And I think this is true with physics, with biology, with any science, with computer science included. You can be very, very good at one particular thing and know absolutely nothing about anything that's slightly off your area. It's like a delta peak in understanding. Oh, Husky, I'll see you around. Thanks for coming in. So hopefully I'll see you around later. Again, I'll be streaming probably every day. I'll try streaming tomorrow again, but again, weekends are 50-50 shot for me. You flip a coin. I might be in, I might not. But definitely on Monday through Friday. So see you around. Anyway, Hypersphere, what I was saying is that just because I'm skilled in one area doesn't mean I'm skilled everywhere. It's like a delta peak in understanding. You really, really understand one particular area, and every once in a while that might be a Gaussian. You might know things around the area too, but generally you get to a point when you just don't understand anything. And for me, that's, even though I work in a quantum lab, I don't understand quantum mechanics very well. And so I know the moment people start talking about things, my eyes just gloss over, and I'm not able to follow effectively. Like, I can follow certain things. Like, don't get me wrong. Like, I can understand it, and I can repeat it, and I can say things, but I can't do what they do in terms of just my analytical skills are crap. I'm very bad with analytics, so I just kind of make up for it for being okay with numerics. Screaming chaotics. Oh man, I wish I was great at everything, but no. Okay, no. See, every time I think I'm gonna write this function, I write it differently. Int box weight. This is why I shouldn't have been typing and talking at the same time. Width. There we go. Okay, let's go down here. 2,000 pixels. No. See, that doesn't make any sense either. Let's just do it. Okay, here's what we're gonna say. How many boxes do we want? We want 3. We probably don't want 4, so we'll say when considering box position, a maximum width of 3 boxes. Good. Okay, fit. Okay, so now let's create the layout here, so we can figure out the width here. So we gave it an initial. Oh man, Gustron just beat me to it. Anyway, so here's the thing. We can create. Let's do it. Let's just make something up. Okay, so. How many will there be? Oh, this is super easy. It's just an if statement. If, let's say we have 5 boxes. What is that gonna look like? It's going to be 1, 2, 3, 4, 5. Okay. So, let's do if number of boxes mod 3 equals 0. Mod 2. let's do a switch. No, that doesn't make any sense. No, yes it does. No, it doesn't. Oh my gosh, why is this so hard to write? Okay, let's do this. Here's what I want to do. I'm going to draw it out over here. Page, new page before. Okay, so here's what we want. If we have one box, this is obvious. One box. Okay, now if we have two boxes, also obvious. Two boxes. If we have three boxes, super obvious. Three boxes. Okay, page, new page before. If we have four boxes, the layout should probably look like this. If we have five boxes, like this. Okay, so here's what we're gonna say. We have three. Hey, Nop, and I think you're right. Real-time multiplayer is a bit tricky. We actually wanted to implement that in our terminal-based academia-themed card game, but we failed to do that because we just didn't have time, and it was a hackathon project, or I guess you could say code jam project. I don't really know the difference. Okay, this is exactly what we want. So, we're going to say if one. Yep, this is what we need. Fantastic. Okay, got it. Okay. Over here. So, we're not going to be able to use a switch for this, so far as I'm aware. We have to use an if statement. So if num box equals 1, then we say, let's do surface width equals box width, and we say surface height equals box height. This is actually kind of fun. It's just super, I'm just worried about it. Okay, so let's go here. Let's say int surface width, and of course surface height. Done. Okay, let's go down here. Let's do else if. Now what do we want? We want to say if number of boxes mod 2 equals 0. Then we want the surface height to be equal to, what am I missing? Oh, you're currently working on a real-time multiplayer browser game. Neat. Let's see, what do we have here? I don't think the server side should be too difficult. Gastorn. Okay, so let's do box width. Okay, now we have to make an executive decision. Height is going to be equal to box height times 2. Okay, so now the question is else, right? So otherwise, it's always going to be 3 this way. So if it's 3 or greater, no. If it's mod 2, surface height is going to be equal to box height times, oh, this has to be number of boxes divided by 2. Getting there, guys. We are totally getting there. Okay, so now finally a big else. And this, I think, should draw everything the way that we want to draw it. So let's go here. And we're going to say that surface width is going to be equal to box width times 3. Then we go down here and we say surface height is going to be equal to, oh, how are we going to do this? We have 3 this way, and if we have 5, I guess this is going to have to be the ceiling of number of boxes divided by 3. Okay, let's see. How do we get ceiling in C++? Ceiling function C++. What do we need to read in? Ceil. Is it read in TG math? Oh, math.h. Okay, that's fine. I figured that was it, but I wanted to check. One second. I will get to the comments in just a quick second. So we're going to do box height times the ceiling of number of boxes divided by 3. So this means if we have 5 boxes, number of boxes divided by 3 is going to give us roughly 2, which is fine. If we have, let's say, 9, this is going to give us 3 exactly. If we have 10, this is going to be put in the other format. So if we do 11, yes. Yeah, this should work. Okay, I think this is fine. It's a hobby project, and I don't really know where it's going, to be honest. At the moment, it's about a space shift combat. That's pretty cool. I have spent more time working on the engine so far. Network 2D physics. Hey, 2D physics is definitely cool physics. So don't look down on 2D physics. A lot of my research has been in 2D physics, and it's pretty cool. Okay, so now we have everything here. So now we do, finally, we create the surface size. And the surface size is going to be surface width and surface height. Okay, so now we have the surface created, and now we create context. Cairo T context, which I'm actually going to call context here, because CR doesn't intuitively say context to me, and this is going to be equal to Cairo create surface. Okay, so now the surface has been created. Now the question is, what do we do? So now we have to draw the boxes. Why not? Just comment exactly what I say. That's good commenting practice. Okay, so I guess we're gonna have the same statements, right? We're just going to create a whole bunch of boxes and draw them at those places. Okay, let's see what happens. So let's go in here, take these statements, and let's say 1, 2, 3, 4, d d d d d d d d d d d d. And I guess in a way, no, I don't think, I think this is the best way to do it. Okay, so if number of boxes is equal to 1, super easy. We're going to say that we're going to create a rectangle that is of the appropriate size and shape in the appropriate position. So let's do it. Cairo rectangle of the current context at the current position, which is going to be 0, 0. And now let it be known, we're going to manipulate this so that it fits and everything. And then we're going to say of size box width and of course box height. There we go. Got one done. Now for the hard stuff. Okay, so now that, oh my gosh. What am I doing with my life? One thing I should probably do beforehand is set the border source and Yeah, set the border source. It's probably fine. So here we go here, and we do Cairo set source RGB. And I don't need an A, it's just gonna be context. And it should be all black, so we want 0, 0, 0. And that should be right. So now we have our black stuff done. Not that there's anything wrong, but I think black will look best here. Now I'm thinking, okay, yeah, so I think we should definitely implement the window thing probably tomorrow if we come back. Because I think that window thing's going to be super useful, and you guys are not going to see its utility until it's actually in the code. But I think it's super useful. Okay, so let's go down here. We have created one box. Now let's create another box. So we're going to do Cairo rectangle. And, you know, I forgot to do something, context. And this is going to be up here. We need to set the line width. So we're going to do Cairo. I think it's set line width of context. And then we give it a size. And I think the size should be dependent on, you know, the size of the, you know, surface, right? So I would guess it should be the size of the surface divided by 100. Let's try it. wait. How big is the surface? The surface is going to be 2,000 pixels long. So if we say divide by 100, it's going to be... Well, okay, maybe this isn't the best way to do it. Okay, let's try another thing. Let's do size of the surface. 20 pixels is kind of big. Here, let's look at the last one. You know, that's 50 pixels. 20 pixels is huge. Let's just set it to 5 pixels for now. And then we'll say we can dynamically change it later. Oh man, come on. There we are. There we go. Okay. So 1 is done. Now we're moving on to 2. So what do we need to do? If it's this way, we now need to create a whole bunch of boxes in the appropriate positions. So, let's see, Cairo rectangle. Let's do it. 4. It's a 2D grid, so we're going to need 2 for loops. Oh, or we could just go through all of the loops. Yeah, we'll do it this way. So 4, size t, I equals 0. I is less than a number of boxes. Then we're going to say plus I. And let's go down here. How are we going to do this? So we're going to say Cairo rectangle of context. Sorry about that. Of context. Now it's not going to be at 0, 0. It's going to be at I times box width. And it's easiest if I do it this way, guys. I'm sorry, box height. You know, I'm not afraid of box width and box height. I'm not afraid of looped loops. So let's go here. 4, size t, j equals 0. Then we do j is less than, how do we want this? We want number of boxes divided by 2. Then we do I plus j. That makes it so much easier, I think. So Cairo rectangle context I times box width. I think this is right. So it's going to be, we have I equals 0. And then we do j next. So 1, 2, 3, 1, 2, 3 should be fine. So if we have 6 total divided by 2, that'll put us into this if statement. Then what we need to do is we just go through and we place all the boxes where they need to go. Should be fine. Okay, so now we need to go down here and we do the next bit. So this too will have to be a double for loop. So 4. Let's just copy this because I am a lazy programmer. Okay, so now the question is, where do we put these rectangles? And these rectangles are going to be put in a little bit of a different spot. Oh, this is going to have to be 2. 2. Okay. And this is going to have to be 3. And this is going to have to be the ceiling of num box divided by 3. And guys, let me know if you have any questions. I'm sorry if I'm just doing things that are really weird or if it doesn't make any sense. I'm just kind of trying to figure out how to draw everything and stuff. This is actually, I'm actually having a lot of fun with this. And I don't know if you guys are, because this might not be the most interesting to watch. Again, we're not doing new physics or anything like that, but I don't know, it's kind of neat, you know? It's just thinking about how things need to go in places and stuff like that. It's super fun. Okay, so number box divided by 3. Okay, J plus J. Now, what are we going to do? We're going to say context, yep, of I times box width. Oh gosh, I did this backwards. Up here, it's going to have to be J first, then I. Because of the way I've done this. No, what am I doing? Okay, if it's 2, then I, J, J, J. So it's going to have to be box width here. And then this is going to have to be J. I had it right before, I think. So it's going to be 0, 0 here. That's fine. Then the next one is going to be 0, 1 down here. Is that right? The next one is going to be 0, 2 down here. Also fine. Okay, so then it's going to be I here. There, yeah, that's fine. This should be fine. Okay, so this should be right. Okay, so now we go down here. And what are we going to say? The problem is that in this case, we have to treat the final line differently. Because it could be possible that in this very last case, we do not have a standard square or rectangular thing to work with. It could be that we have to work with an oddly shaped box or something like that. So how are we going to do that? We're going to do that by chiral rectangle, I times box width, J times box height, box width, box height. Anyway, guys, if you have anything to say, any questions you have to ask, anything like that, again, it doesn't have to be about this project. It could be about physics or math or computer science or something you saw in the news recently. Just let me know. Again, this is kind of more of a chill day. So we just kind of work on, or talk about, work on things. You know, it's just, yeah, it's fun. Well, for me anyway. I don't know about you guys. So context. I times box width. So that'll be 1, 2, 3. But this guy right here is going to have to be seal of box divided by 3. I guess minus 1. And then we treat that last line differently. Okay? And now we say yeah, we'll treat that last line differently. So we're going to be out of these two for loops. And we're going to go here. Is that right? This looks wrong to me. Oh, now it looks right. Okay, we're fine. Okay, so now we're going to say for size t, I equals 0. I is less than. It's not going to be 3 in this case. It's going to be numbox box mod 3. Wait. Okay. I'm trying to figure out how to place these boxes, right? So the idea is I want to place them something like this, right? So let's say we have 5 boxes. Let's go through this and see if it works. So if I is less than 3, ceiling of numbox divided by 3 is going to be 2 minus 1. So this should place 3 boxes on the first line. Now for the second line. Numbox mod 3 is going to give us 2 in this case. So this will put it into the appropriate spot. Yep, this should work. And then I'll deal with the next case in just a second. So then we're going to do plus plus I. Pretend I can actually code. Okay, and now we're going to say we have to center them. So what we're going to say is the following. We're going to say Cairo rectangle at current context in the position of, this is gonna be a weird position, but hang in hang in here. It's going to be surface width divided by 2 minus box width. Okay, that's going to be of the first one. So it's going to have to be we're talking. I'll see you around. Thanks for coming in. I'm sorry your day wasn't too productive. Hopefully tomorrow will be better. Box width, and then the layer that we're at is going to be equal to ceiling of numbox divided by 3, I think. So this will be ceiling of numbox divided by 3. And then, of course, box width and box height. Okay? That should work. And let's do it this way. Okay, I'm thinking here. If we have 3 boxes on a single column or a single row, right, and we add 1, we're always going to get 4. So we're always going to run into the case where numbox, we're always going to run into this if statement. So what I want to do now is I want to go through and I want to change this up a little bit. So here's what we're going to do. We're going to add a switch on numbox mod 3. Let's go down here to the bottom. Add in an ending here, and then let's do some indentation. So we'll set number. And this is going to have to be from 105 to 114. We're going to do S. Then what do we want to do? We want to say at the very start, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, now we're going to set no number. Good, and it still fits. So here's what we're going to say. We're going to say case 0. Oh, case 1. No, 2. We do this. And now we need to add 1 for case 0. And that should simply be these loops right here. Except that this guy is not going to have a -1. Okay, So, does this make sense? Surface width divided by 2 minus almost, except for this bottom one. So it's not minus box length. It's going to be minus, we have 2 of them. So it's going to be minus box length if I equals 0. So we're going to do I minus 1 times box length. Holy crap. So let's go down here. Let's put this here. There we go. So it's surface width divided by 2 minus I minus 1 times box length. That should be right? So if I is equal to 0, because we only have 2 cases to deal with, if I is equal to 0, then we have minus 1, and let's change this to a plus. We have minus 1 times box length. So we're subtracting a box length. And if it's equal to 0, or if it's equal to 1, which again is the only other one we have to deal with, hey Slayer Darth, should be fine. So in this case, since we've already done this numbox mod 3 calculation, I'm going to set this equal to 2. And that should be fine. It is, no, it's 6:36 in the morning, so it's almost 30 minutes till 6. Okay, now finally, after all this has been drawn, we simply have to do the following. We do Cairo stroke context. Is that it? Is that literally all we have to do? 1 second, let's go up to the top. Cairo stroke, yeah, that's it. Okay, then we go down here and we return context. Good. No, I know. It is 6:36, so we are 25 to 7. Oh wait, are you 25 to 8 in the morning? Where are you then? Australia? No. Yes? How far away is New Zealand? I don't know. Okay, so return context. Now let's go up here. Let's make clean. Make. Okay, obviously there are some errors. Let's go ahead and fix all these errors. So first of all, on 62. Cairo create, what is the problem? Return Cairo T is incomplete. What? Create scene is incomplete. Ambiguating new declaration of void create scene. Create scene. Okay, let's do it this way. Let's change this function to a void for now. Go to the top. And that's fine. It's not a big deal. Void. Okay, let's go here. Let's make clean. Make, and that should probably get rid of those errors. Now we just have a couple semicolons that I missed, which is perfectly fine. 100. Let's go here, add that guy there. And 110. Obviously because these were copied, because I'm a bad programmer. Okay. Write this, go over here, make again. And what's the next one? Return context. Yeah, because it's void, we don't have to return anymore. Okay, let's write this, go over here, make clean, make. Okay, now let's go up to main. Again, this is what I was saying before, because main's in all caps, it's super easy to find. And what I'm going to do is I'm going to comment all of this out. And then I'm just going to try to see what happens if I make the scene. Sorry about that, guys. Okay, so we have create scene. Let's just run that and see what happens. Okay, so we're going to do create scene. What do we want? Let's do just one box. Box width is going to be 500. Box height is going to be 500. So let's make clean, make comparison between signed and unsigned integers. That's fine. Let's go ahead and fix that one. So this is going to have to be int. Oh. To be fair, this is always going to be positive. Yeah, okay. So now let's do ls. We should have subroutine.png, ocular. Let's just run the last ocular command. Let's remove subroutine. Oh my gosh, I forgot to, yeah, okay. That was my bad. So I commented all this stuff out, which means I never actually drew it anywhere. So let's create a separate function for writing. Nah, let's just run this. Nope. Well, let's see what happens. Over here, make clean, make. CR was not declared in the scope. Of course not, because I'm an idiot. No, let's comment this out. Just because the stream's almost over and I gotta get something out. So let's do this. Writing, destroying, rendering device. Down here at the bottom, after Kairos stroke, print this. And let's change this to context. Okay, surface, sounds good to me. Right here, let's go to make clean, make, and now let's ls, and we should have a subroutine.png. Let's look into the subroutine. One box, perfectly outlined. Fantastic. Okay, let's try this with 2. Oh gosh, it's gonna break at some point. 2. Make clean, make, and ocular subroutine. 2 boxes, no problem. Okay, you guys ready? This is what I'm worried about. 3 boxes. Make clean, make, ocular. All right, that's way more boxes than I thought I was gonna get. That's 6 boxes. Dang it. Okay, so let's go down and let's do it. What is the problem? We got 6 boxes when we were supposed to get 3. So this has to be in the evaluation of if I is less than 3. How did we get 6? How did we get 6? Okay, so size t, I equals 0, I less than 3, I plus plus, or plus plus I, whatever. Size t, j is less than CL of numbox divided by 3. That should be... Besides, that doesn't matter. Context I times box width. What happened? Wait. What if this isn't 3? Or what if this isn't 6? This, in fact, cannot be 6. This has to be 5. Okay. Now, I realize that sounds weird, so let me explain this. The way this is a 5. Oh, come on. How do you... There we are. Okay, so I know it looks like there are 6 boxes here. But actually, it's 1 box here, 1 box here, 1 box there, and then 2 additional boxes here and here. 5 boxes. And that's because each box has to be square. I set it 500 by 500. So it has to be 5 boxes, which means for some reason, when I put in 3, we're not going to 3. So let's go and let's see which case we're in. Let's go down here and let me see out something. STD, see out. Oh, 1 second. We are in case 0. End line. And we're going to do the same thing down here. STD, see out. We are in case 2. Then end line. Write this, go over here. Make clean, make, and let's do, we are in both cases. What? Okay. Let me see out something real quick. Let's go up here and let's see out std, see out, and then we're gonna say numbox mod 3 equals and then of course numbox mod 3 end line. Make clean, make is equal to 0, so we should only be in case 0. Under what situation would we want to go to case 2? Why are we in case 2? We shouldn't be. Oh, did I forget to break? Is that what happens if you forget to break? Make clean, make. Yeah, that's what happens apparently. So let's go into ocular. And we have 3 boxes. Fantastic. Okay, so now let's go through. Because clearly case 2 was not working. But let's go through box by box. So the next thing we need to do is go to 4. 4. Right over here, make clean, make. Ocular. Okay, this one worked just fine. Look at that, 4 boxes. So I'm gonna try 6 now. And I think this should also work. Let's see, make clean, make, ocular subroutine. 6 boxes. All right, this one's working just fine. Okay, so now the next question is 5. Let's go to make clean, make, and then we do ocular subroutine. Huh. Only draws 2 boxes. Okay, let's see what's happening. So, SDC out, we are in case 2. Clearly. Okay. So, SDC out, we're in case 2. For size t, I equals 0, I less than 3 plus I. For size t, j equals 0. J less than ceiling of numbox minus divided by 3. For 5, that's 2 minus 1 plus j. Oh. We don't need the minus 1. Let's try it one more time. Make clean, make, ocular subroutine. There we go. Now we have 5, but we have a bit of a problem. Okay. What is the problem? The width, I think, is in the appropriate spot. The height, however, is not. But more than that, the canvas size is wrong. So let's see if we can fix this up. So what's wrong with the canvas size? The canvas size is appropriately resizing. Sometimes. So when considering the box position, we assume a maximum width of 3 boxes. That's fine. So surface height is going to be equal to box height times ceiling of numbox divided by 3. How's that not right? I would think that's totally right. Plus 1? Ceiling of numbox divided by 3. Let's go down and let's print that out. Here. That's perfectly okay, Slayer Darth. Everyone's kind of sleep deprived. All right, we've got 10 minutes. You think we can finish this in 10 minutes? I promised some friends I would hang out today, so that's something. So let's divide this by 3, and let's do ceiling of numbox divided by 3. And I think this should be 2, but just to be clear, I would like to check it out. Ceiling of numbox divided by 3. Let's do make clean. Make. Let me see. It's equal to 1. How is that equal to 1? Numbox divided by 3. So 5 divided by 3 will give you 2 and... What? Fine. Round up. What? Seal of 2.3 is 3. Seal is the right... Yeah. 9 to 6. I mean, standard job, right? 9 to 6. And then it took the train back home, arrived at 7. Yeah. Then helped out with preparing for a local street party. Oh, dude, you had a street party? Yeah. So what do you guys do for the Queen's birthday exactly? I don't understand, like, what kind of celebrations are involved there. So now I'm going to see out something else. STD, see out. And what do I want? I want numbox divided by 3 equals the following. Numbox divided by 3. Oh. I know why. There we go, integer division. Let's do it. You prepare a sniper rifle. For who, Trump? Okay, so we want ceiling of double. Oh gosh, that could probably get me in trouble if I said that. I didn't say that. I mean, there was no threat there, for the record. Okay. Double 3, let's go for all the ceilings. And let's fix all of them. Yeah, that should be fine. Ceiling numbox divided by double of 3. Oh, why don't I just put a 0.0? Oh, cool. That sounds lots of fun. Box height is equal to numbox divided by 2. Should be fine. Let's just change all these up. Let's do 0.0. Where's the next seal? Oh, I need to go down. Here we are. Next, seal of numbox. Next, seal of numbox. Next, seal of numbox. Okay, let's try this. Go to make clean, make. Now let's see what happens if we do ocular. Okay. Still a little bit different than I was expecting. What? Okay, what's happening here? 1, 2, 3, 4, 5 up top. Let me remove. No, it's fine. I'm sorry. I should not have made that reference. I understand if people are angry with me about that. That was just, I was out of line with that. That's fine. Okay, so let me do remove subroutine.png ls, and now let me do /subroutine. Okay, now let me see, what do we have here? What I want to do is ocular. Here we are. Good. Okay. See, that's the thing I don't like. Hey, Chicken Scale, thanks for coming in. 1, 2, 3, 4, 5, 5. They're drawing the same line. That's not how it should be. So how should it be? It should be, we're in case 2. So we're saying for I++, j, should this be -1 still? Oh, it should still be -1, I think. Make clean, make ocular. Oh, what did I do? So for size t j equals 0, j is less than ceiling of numbox. So this would just be one iteration. We're clearly drawing these 3 correctly anyway. Then so for size t, I equals 0, I is less than 2. We're going to draw on surface width divided by 2. That's perfectly fine. I -1. These are actually being drawn in the right place. Then this one. Oh! This one is not drawn in the right place. Ceiling of numbox divided by 3.0 is clearly not the right place. That is that's 2. So it's going to be this times. Actually, this -1 times box height. And then we need to put these guys on, the following line. And there we go. We're going to make clean, make. Now let's see what happens if we run ocular. Okay, there we go. 1, 2, 3, 4, 5. Done. So now let's check out a couple of different numbers just to make sure everything is fine. Let's go up to the top. We've already tried 6. Let's try 7. Let's do make clean, make. Now we're going to do ocular. Yep. I thought we missed one. Yes, that's exactly what I'm doing right now. I'm making the tile manager for a comic. Okay. So 7. Where does 7 fall? What did I do? I clearly missed the case of 7. 8 should be fine. Make clean. Make. Let's do ocular subroutine. Yeah, 8's fine. 8 does exactly what we expect. 1 obviously does what we expect. 5 does what we expect. So let's do 9 should also do fine. Make clean. Make. And we'll do ocular subroutine. Yep, 3 by 3, perfectly fine. 10 should also be fine. So let's do make clean, make, and then we're going to do ocular subroutine. Oh, 10 did it a little differently than I anticipated. That's fine. Okay, so we apparently missed 7. Where does 7 fit in here? So it's going to be 1, 2, 3, 4, 5, 6, 7. Oh, 1, 2, 3. Oh. Huh. Where would 7 tiles fit? Huh. I'm actually not sure. Okay, so here's what I'm going to do. I'm going to go ahead and right quit this. And then I'm going to git branch real quick, just to make sure we're on beta. Now we're going to do git commit. Oh, 1 second. Subroutine.cpp. No, not quite like i3. It's more like a here we're just creating the tiles to work with. And tomorrow we're gonna do something special. I think I'm gonna come back and work on this tomorrow. I had a lot of fun working on this today. Okay, so we'll see though. So again, I will post below, or I will make a note on stream if I'm not able to make it tomorrow. And like it'll be in the title, or it'll be in the little notes underneath the stream or something like that. So -m, adding tiling for multiples of 3, 5, 9, 3, 5, and 2. Now, where does 7 fall? Let's see, so 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I'm not sure. Some numbers. Let's just do this. I'm going to do it a little bit differently. We're going to do git add subroutine.cpp. And then we're going to do git commit. And I'm going to say added tiling for multiples of 2, 3, and 5. There we go. I use the Sakura terminal. Okay, so now we do adding tiling for these. Missed a few numbers, but cannot decide how to place them. Later, these will be turned into windows. Okay. Right quit, git push, origin beta, beta. Hey, Ago Rix L. Okay. So, unfortunately, Ago Rixel, you came at the very, very end. of my stream. It's 7 o'clock in the morning my time, which is typically the time I end my stream. I guess I could stay a little bit longer, but we hit a pretty good stopping point right now. So we are now able to draw boxes of, appropriate size. So let me go back into VI subroutine, and let me try 13 real quick. I think 13 is another missed one. I think I'm just missing primes. I really think I'm just missing primes. So let's do make clean, make Oculus subroutine. Yeah, so I think it's primes that I'm missing, because if I go to 15, we should totally see what I expect. So let's do make clean, make, and then we're going to go to Oculus subroutine. Yep, so 15 is exactly what I'd expect to happen. Good. Sakura, like the flower in Japan. So Sakura. And it opens up a Sakura terminal. Whoa! It's just a lightweight terminal that I use all the time. So anyway, guys, we are now able to generate the appropriate boxes in which we will be putting information in for later. Now, this is not to say this is the end-all, be-all of how we're going to be putting in this kind of stuff. We're going to be doing a lot of stuff with this in the future. This was kind of just a test to kind of get used to how Cairo works and stuff like that. And honestly, it was a lot of fun. I'm quite looking forward to seeing how this project continues in the future. That said, we're still a significant distance away from being able to draw like actual shapes and objects and things like that. So stick with us for that. I will probably be back tomorrow working on this, but if I'm not, I will let you guys know somewhere. Either it might also be on Twitter, it might be on a number of different places, but I'll definitely let you guys know somewhere. But probably will be here tomorrow. And then again on Monday, we'll continue working on the dense matrix renormalization group physics simulation, which should be a lot of fun. So, all that said, thank you guys so much for watching. As always, I really do appreciate it. Again, you can find all the stuff that we did today on, let's see, should be my GitHub profile, which is linked under the stream. And then it should be repositories. Oh, I can add a bio. Sweet. Subroutine. And then it's going to be in branch beta. Right now, I think all we have is a simple subroutine.cpp file, and it's not particularly long. It's just about 146 lines. Anyway, guys, thanks so much for watching, and I will see you guys next time. Have a great day, night, afternoon, morning, whatever time it happens to be your time. And I guess that's about it. So, see you guys around. Bye.